In this chapter, at first, we will learn how to find out the formula or the value of small g. Small g, that is gravitational, that is acceleration due to gravity. We know the formula from our last videos. Force, gravitational force F equal to capital G, gravitational constant, capital M, small m by r square. And we also know that force equal to mass into acceleration or mass into gravitational acceleration due to gravity. If something is falling towards the earth, then it is known as acceleration due to gravity. These two, and this one, these formulas we know. From here, I think we can write that this F is equal to capital G, capital M, small m by r square. As we can write this, so from here we can write it that the value of capital G is 6.7. This value of capital G is 6.7 into 10 to the power minus 11. And if you will see, if you will compare these two formulas, then you will see small m will cut off, and here only a will be there, and here capital G, capital M by r square. The value of capital M on earth, capital M means mass of earth, in case of acceleration due to gravity or capital G or small g. This m also cut with this. If you will compare these formulas, then this m will be cut. Here this mass of earth is 6 into 10 to the power 24 kg, and r square, that is the radius of earth, is 6.4 into 10 to the power 6 square. If you will do the calculation, then you will get the answer is 9.8 meter per second square. This will be the answer, that is small g, acceleration due to gravity, is equal to 9.8 meter per second square. So I hope you have understood how we have found out the acceleration due to gravity. Now we know three equations of motion, that is motion of object under the influence of gravitational force on earth. If we will see about the motion of any object under the influence of gravitational force on the earth, then we need to use three formulas as we have learned from the equations of motion. That is, the equations of motions are v equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. These are the three formulas, three equations of motion we know. As we will compare this with the earth's gravity, then we can use this. This a will be just replaced with g. A will be replaced with g. That acceleration due to gravity. Now we will solve some questions. Before solving question, I would like to derive one more formula, that is the weight of any object on earth and the moon. This formula we will identify first, and then we will go to the mathematical problems. Now we know that if any force F equal to mass into acceleration, or which is same as mass mg, mass into acceleration due to gravity, and this force is known as W, weight of any object on the earth. From here, what we learned that W is directly proportional to m if g is always 9.8. As g is always 9.8, so W is directly proportional to m. We can say this. So how you will find out the weight of an object on the moon? So what we will use? We will use the formula of, very simple, as we have used here. If you will see the weight of anything on moon, then that is the weight is mg. M means what? Mass of the object. M means what? Mass of the object, that is small m, and g is what? G, from here we can write that small g. From here we can write that small g equal to capital G m by r square. As you can see here, small g equal to capital G m by r square. You see, from here I have written small g equal to capital G m by r square. As we have seen the three formulas of motions, equation of motion, and we have seen that F equal to mg from here we have found out that small g, acceleration due to gravity, equal to capital G capital M by r square. So if we need to find out the weight of anything on moon, then we need to replace this capital M with the mass of moon, and then we need to compare accordingly. Now how you will find out mass of anything on the moon as compared to mass of anything on the earth? So now let's see what we will do. For example, weight of anything in moon. So we know that force equal to F equal to mg, so W equal to also mg. Weight equal to mass into acceleration due to gravity. W equal to mg, weight equal to mass into small g. That mass of any object we will keep it constant. For example, let's see capital small g equal to capital G M by r square, as you have seen here. Then and one small g will be there. Now as we are finding the weight of any object on moon, so it will be small m. Now gravitational constant will be constant everywhere, and m I am keeping constant. Now the mass of moon is 7.36 into 10 to the power 22, and the radius of moon is 1.74 into 10 to the power 6 square. Now if you will calculate here, then we will get that it will be 2.43 into 10 to the power 10 capital G small m. This will be the value. Capital G small m. This will be the value. And now if you will compare both of these, if you will find out the ratio, that is weight of moon, weight of anything on moon by weight of anything on earth, then it will be like this: 2.431 into 10 to the power 10 into capital G small m by it is by 1.474 into 10 to the power 11 into capital G small m. And capital G small m will go, and then we will found that Wm by weight of earth is equal to 0.165, which is near about equal to 1 by 6. That is weight of anything on moon by weight of anything on earth equal to 1 by 6, implies weight of anything on earth equal to 6 into weight of anything on moon. So if anything's weight, for example a apple weight or a big watermelon weight of 1 kg on earth, watermelon weight 1 kg on earth, then the weight on moon will be 6 kg. So I hope all of you have understood till this much, and there will be no confusion here. And now we will go to the mathematical problems, some other mathematical problems. So to go before the mathematical problems, I hope all of you have understood all the formulas, and to find out everything, I hope all of you know how to find out each and every problems, everything related to the gravitational force. Now let's see the first mathematical problem, that is on your NCERT book. It is example 10.2. Now 10.2, the question is that a car falls off a ledge and drop to the ground in 0.5 second. Let g equal to 10 meter per second. Number 1, what is the speed on striking the ground? Number 2, what is the average speed during the 0.5 second? How high is the ledge from the ground? These all things we need to find out. Time t equal to 0.5 second. Initially, see, a car falls from a ledge and drops to the ground in 0.5 second. Initially, that means the car is at rest. Initial velocity u is equal to 0 meter per second. And acceleration due to gravity, when the for example the car is here, it falls towards the ground, that means acceleration due to gravity g will be there. G is 9.8 meter per second square. And then acceleration of the car, acceleration, for example a, we will take, it is going towards the ground, so near about it is 10 only, 10 meter per second. 9.8 we are writing as 10 for betterment of our calculation. For the first part, in the first part what they said, what is the speed on striking the ground? So when it will strike the ground, what is the speed? That is final velocity. We know the formula, that is v equal to u plus at. Here you will write v No, v equal to u plus at. If you will write it, then what you will see, v equal to u is 0 plus a, acceleration due to gravity is 10, acceleration is 10 and time is 0.5 second, that is 0.5 into 10, that is 5 meter per second, that is final velocity while striking the ground is 5 meter per second. Now if you will see number 2, in number 2 what they have asked, what is the average speed during the 0.5 second. Now see, average speed, we know how to find out the average speed, that is average velocity is initial plus final by 2. The initial is how much? 0 second, final is 5 divided by 2, that is 2.5 meter per second. Now on the third part, what they have asked, they have asked to find out how high is the ledge from the ground. Now you have to find out the height of the ledge from the ground. For example, this is the ground and this is the ledge. Now you have to find out the height. You have to find out the height from the height of the ledge from the ground. Now this means this is the distance traveled by the car before touching the ground. Now we know that s equal to ut plus half at square, s equal to ut plus half a t square. So this a we can replace with g, that is ut plus half g t square. Now if you will write here s equal to ut plus half gt square, u is 0, so it will become, this term, entire term will become 0 plus half g t square. Now s equal to half gt square. If I will write from here s equal to half gt square, you can see here half g is 10 and time is 0.5 square, that is the answer will come is 1.25 meter. So I hope all of you have understood this question. If you have any doubt, you can tell me